boom.
My voice says make room.
Make room.
Wave a hand, combat the gloom. When the ache comes creeping up, I spread my arms so wide that soon my best starts to bloom with the breath that I consume. And I grow like grass on a hillside, it's the way I leave my tomb.
Hey, what's up everybody? I'm Turbo and welcome to my first Turbo tutorial. Maybe my only one, who knows. I normally do unboxing on this channel, but I was recently notified that my friend Doug would like to know more about 3D printing, and so I thought I'd do a quick video, try to do a quick tutorial, keep it about 5 or 6 minutes like my unboxings, but try to give you an overview of what's going on with 3D printing. So just for starters, really basic level, 3D printing is basically like 2D printing with a third dimension. So you are bringing a digital computer file into the real world. Just like with a 2D printer, you are bringing a digital document into the world. This brings your digital model into the world. And this is my 3D printer. It's kind of an open source DIY type printer, which makes it kind of inexpensive. And really, these are the kind of printers that are driving the 3D printing revolution right now, because people can afford them. You can have it at your house, and you can crank out all sorts of interesting models. So I'm going to get to the models in a sec, but first I'm going to start by talking a little bit about the materials, because everyone always asks about the materials. You can see up here there's a spool. It's hard to see what's going on from the side though, and this is what that spool looks like front on. And it's basically a plastic thread, if you will, a thick plastic thread. And what happens is this material goes through a metal piece here called the extruder, and the extruder gets very hot. For this material, we set the extruder at about 200 degrees C, and so, but it's very localized heat. So the plastic goes through, it melts, and then it cools as it comes out the other side, and the extruder deposits it first on the bed here, and then on, you know, your previous layer of plastic. And now talking a little more about the materials. In general, you are using plastic, but plastic's a very generic word, really. This is called PLA. Okay, it's on the label here. PLA is polylactic absorbic acid, I think, and made in China. Everything is, right? That's funny. I'm making stuff here, but the material's still made in China. Anyway, this is actually a very cool material because it's based from corn oil and plant oils, and it's compostable, I hear. I hear it's kind of biodegradable, industrially biodegradable. So it does biodegrade over time. It's a much more natural material than a lot of your other plastics. Although this printer can use all sorts of different materials. I've got a few others here. This one I haven't cracked open yet. I'm excited to try it, and I should speak without rattling. And it is a carbon fiber PLA. So this is basically a PLA material with carbon fiber particles and particulates inside of it. So that should make a stronger part. Although I don't know how strong it's going to be. When you come down to the strength factor of carbon fiber, it's because these fibers tie together. I mean, you know, they're long fibers, and they create a bond. So I don't know if particulates are going to make it stronger or not, but it should be a cool experiment to try out. Is a wood filament here. You keep it in the bag because it's sensitive. This filament in particular is sensitive to moisture. You can see it's brown, and it's again a PLA matrix with wood particles. The material isn't that expensive, and it does go a long way, so that's pretty cool. This spool cost me about 15 bucks, I think. Wow. Okay, and I am going to be much longer than 5 minutes. I see now from my time, but that's cool because I don't want to miss anything. A little bit about the files for a second here, because the files aren't super straightforward. There's actually a lot of variables you have to set. I'm not sure if the camera's picking that up. I was having a hard time with the monitor. There's all these variables, and they change depending on your machine. They depend on the material, and they depend on the model actually, and how nice you want your model to be. You can go a high resolution model or a low resolution model. Low res is faster, you can crank them out, but high res looks a little nicer. So for example, this Thanos here that I printed him out while I was away for a weekend at a very high resolution and low speed. And so he looks really good. There's smooth lines. The striations, which are these lines, which are kind of the hallmark of a 3D printed part, are minimalized here on Thanos, although my printer wasn't the best aligned and it needed to be oiled when I printed him. So it's doing really good now. It's cranking now. And I'm going back to the file now. There's two different ways to manipulate the file. This is what's actually called a slicer. And you have to use a slicer to take a 3D model and put it into the kind of code that the printer can read. But you don't design your part in the slicer. There's different software that you would use to design the part. This is a simple software called 3D Builder that came with Windows, so it's free. And right now I'm using it to tear apart a Batmobile and make the wheels spin, so I can do printable spinning wheels, and they're going to be print in place. I just learned how to do this. That's the fun part about downloading these models and printing things, is they teach you kind of how to do your own models. So, and I do want to talk about that a little bit. Most of these models here were not designed by me. And if I display them, I'm supposed to give credit, and so please look below in the comments. I'm going to try to put the links to all this stuff. I might miss one or two. If I do, give me a shout out and I'll get it updated. I want to give credit where credit is due. A few of these I did design myself, and so that's kind of fun too. That's a good power of it. This is actually a perfume sprayer bottle. It really works. This one's empty, but and I used the wood filament and I stained it, so you can see a difference between the nozzle sprayer here and the body itself. I did not stain the nozzle, stained the body, and that's kind of neat that the wood filaments can take the stain. It gives it a whole new dimension. That was actually my first design that I tried to do by myself. There's a few things you can download, files that are customizable, like the name tag sign, the name sign, the desk sign, if you will. I was doing this as kind of a fun video thing that I haven't gotten around to using yet, but Darth Vader, Vice President of the Empire, of course. Not of the country. That's not a dig at Patsy. It's not Vader-esque. Nah, there's different stuff going on there. Anyway, focus. Okay, I'm going to talk about the printer itself a little bit now. Some of these parts I actually printed myself to add to the printer to increase the capacity of the printer. The spool holder. This was the original spool holder. It sat off to the side. I wanted an integrated one to take up less space, and it feeds better into the extruder also. Now this is the extruder. And I printed out an additional fan duct to do better cooling, because the cooling is important also. It's an interesting balance for temperature. You need it hot when it comes out, and you need to cool it properly or else it'll warp. And I'll show you an example of that here in a minute. And so this thing has 3 axes, and I'm going to show you it running, but it's kind of noisy. It can be noisy, and so I didn't want it being noisy while I was talking about it. But we will show some running of the printer before the end of the video. Maybe it'll be interspersed when I cut it. I don't know. Anyway, but so it does have 3 axes. It's got a y-axis in which the table itself actually goes back and forth on a motor with a belt, and this is the x-axis. And then the z-axis takes this entire trundle up and down. controller card. I had to wire everything up myself, but you know, it was connectorized. It wasn't too hard. It took me about a day and a half to put the printer together. One of the reasons is that this heatsink, it was supposed to come with a heatsink, it didn't come with one. And so I had to go find this and kind of make it fit, chop away at it with my Dremel a little bit, but it's working good now. It hums pretty good. Like I said, it's kind of noisy, but it makes good prints. It just plugs into the wall. It doesn't really come with a switch or anything. I was going to wire up a switch. I haven't gotten around to it yet, but I do have it plugged into a power strip, so that's kind of my switch. Every once in a while, this is a sensor actually that senses when it's close to the bed, and occasionally this will get misaligned and it'll try to drive itself into the bed, so I have to switch it off real quick and reset it and realign it. A lot of the print quality is based on alignment. You know, it's your settings, make sure it doesn't go to sleep. It's your settings in your slicer, but then it's also the alignment of the printer, so that's important. I keep some small levels around here, make sure I keep it aligned. Sometimes I'll even align it in real time while it's printing the first layer if it looks a little out of whack, and I'll even restart a print. I'll stop and restart if it doesn't look right, because you don't want to waste material.